This video is meant to give you a bit of a feeling about the ABAQUS user interface. Uh, it's only a very short introduction. The reason is that we will explore all the different options much more in details as and when we do different exercises with tutorials in the practical classroom. So let's just go through this very quickly. So if you see, this is your standard ABAQUS CAE for the student edition of the 614 version. This is what all of you will be downloading, and having installed it already, I hope you'll be able to follow step by step all the processes that we have been discussing in the theory lectures. I will also do some tutorials with you, and you can follow me as you do it, or you can watch the video and try it on your own later. So when you launch ABAQUS CAE Student Edition, this is what you will see. This is the start session, as you can read here. You will be given a choice to create a model database with standard explicit models, for a CFD model, for electromagnetic models. So there are different options, or you can also do some tutorials which have been provided by ABAQUS. With the linear modeling course and with the mechanical problems that we will be dealing with, it is only the standard explicit model that we will be using to create any kind of model database. If you have worked on certain examples before or certain exercises, you will see them here as well. It would be wise to set your home directory for ABAQUS CAE to be your working directory. So what I do generally is that I have a folder called ABAQUS Jobs, where it always, when I launch something from ABAQUS, then everything is stored into that directory. All the files that are created while running the analysis are also stored in over there. So it always makes it much easier. Otherwise, if you're using the university computer, it generally stores everything in the scratch directory, which is deleted every so often. So it's possible that you might lose all your files. For your reference and for learning purposes, for taking the exercises forward, I would suggest that you make a separate folder for all your exercises. Save everything all the time so that you have all the versions of the models that you have created. So I'm also going to start with a new model. So I just say I want a standard explicit. You will see here there are all kinds of messages that show up. So if you have asked the user interface to perform some action, it will give you a message here whether it was done or not, what was the problem, if it wasn't carried out, etc. So make sure you are looking at this all the time once you have clicked on something, to see if actually the operation that you requested for has been carried out or not. What you see here is that this is where you get the message area, and here you can, this is the kernel command line interface, and here you can actually write commands using Python so that it can work out some details. So we will look at this later. It's not so important right now. Let's just keep it to the message window, where you should keep an eye on. Always, you can always increase or reduce the size if you find it too annoying. You make it small or you make it larger if you want to see everything. But I would say keep a minimum amount so that you do know what's going on. Then this is the model tree. If you see, if you just, I'm going to uncollapse it, and you see that you only have two parts in it. One is which says what are the models, and then the other one is the analysis. Under models, you can have multiple models. This is one which is always set as default, model 1. You can create more models by double clicking here. So you say, okay, I want to make a new model, and that's called model 2. You can also change the name once a model has been created. So if you have model 1 here, you can do right click, rename, and you can name anything you want to. Under the model, you will have different properties that you can put in. So you have to create a part, you have to apply materials, you have to do some calibrations on it, apply a section property. What is the profile looking like? For example, what's the cross section if you have to provide something? And once you have created all the different parts of your problem, you can assemble it all together in this section called assembly. Instances are nothing but a repetition of these parts that are imported into the assembly. You can place them all relative to each other. So all these instances, when put together, can form a complete structure or a complete problem that you're trying to solve. We will go through all the details once we pick up an example problem. So once you've set up your model, so you can see this is quite in the terms of the pre-processing step. So you have all the definition of all your parts and materials and properties. You've also created an assembly of all the different parts, and then comes the part where you have to create a certain condition. So what are the loads and boundary conditions that you're applying? And in ABAQUS, you always have to create a new step here. The first step by default is always given as initial. This is where you can put in all kinds of initial boundary conditions. So you have initial conditions. So if your object is moving at a certain velocity, then you can provide it as an initial condition with prescribed velocity. If you have as an initial condition something that's fixed, you can also put it here. So the only things that can go in the initial step are certain kinds of boundary conditions, which we will see later. And when you want to apply a certain load, you will always have to create a new step, which can also be renamed over here. And by default, it's always even step 1, 2, etc. You can also choose what kind of step it is going to be. So basically, what kind of analysis do you want to carry out? Is it a static general analysis? It's a RIX analysis? These are things that we don't have to go into a lot of details now. All you have to know is that we will be carrying out everything in the general static step. That's just the basic linear analysis. Then once you have created a step, you can request for all kinds of outputs over here. What do you want to see as an output? So primary and derived results can be seen here. And before that, of course, all kinds of loads and boundary conditions can be attached. As you can see, you can only add loads and boundary conditions when you do have a certain assembly which is created. So this is the part up to which you have already known that it's a pre-processing step. So you apply the loads and the boundary conditions, so your model is complete. After that, you go into the analysis phase, which is actually the processing phase. Within this, you create a new job. You can attach it to a certain model or a certain input file. We will look at that later as well. So you attach it to a certain model. Once you create the job, you can just right click on the job and say run. That's when it's going to process it for you. And if all your conditions, all your preconditions are correct, your pre-processing step was set up in a useful way for the analysis to run. I can't say whether it's correct or not because that would be reflected upon by the results. You will see some results. And the result section or the post-processing, I will show you after we have carried out a certain problem. So this is the model tree. Now you can see that this is one of the parts where you can always double click and create things. You can just go to any part and say, okay, I want to create a feature, blah, 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 and then you can do a lot of things. The same thing you can see here under module. So you see the module, you have the same sections or headings here as you have seen here. This is quite an easy way of carrying out a FEM analysis. So you see, first you create a part, you assign a property, then you assemble it, you create a step. Are there any interactions or boundary conditions? Are there loads? Do you have to mesh it, of course, because that is the discretization step. That's what we will learn while we do all kinds of analysis, what kind of job you want to create, etc. Here you can also see that you can have a list of models. So all these drop-down menus are going to give you a lot more options. So it's actually the same thing that you see here in the tree, put in a nice drop-down menu. Now, under certain conditions, so when you're in part, you will see some specific tasks that you can carry out with options over here. If you change to an assembly, you will see that these options will change. So if you hover over them, it'll give you what it means. So if you have an instance in the assembly, you want to rotate it, you can use this. If you want to move it or translate it to a certain part, you use this option. And if you sometimes, there are more than one, so you see a little arrow here. So if you keep it pressed, you see all the different options that you can carry out under this category. Now, this is not, if this wasn't enough, there's also a drop-down menu in the toolbar here. So if you click on model, you will be able to see most of the things that you have here, but in a different format. You can manage conditions here, instances, moving. So it basically is defined in 3 different ways. You can have a tree which defines everything for you. You can have drop-down menu, or you can have a toolbar which is set up on top. So all in all, there are many ways. Find the way you find comfortable and work with that. What you also see is a number of options over here. These are all toolbars. So if you go to view and you go to toolbars, here if you have something unchecked, that one particular section or toolbar will go away. which is all belonging here. Some of the most important ones are view options, views, display groups, and viewport. So if you want to have more than one viewport, look at these options here. So you have one viewport. If you want more, it makes it smaller, and you have two of them. You can place them one on top of the other. You can place it side to each other. You can also link them. So if you move objects around in the two windows, they move around in the same orientation. So this is all possible with these kind of toolbars present here. Another very important one is this one. It's a query button. You will be using this to pick up certain nodes, elements, points. If you want to see what the mesh is like, what is the mass properties, etc., they all come up here. And if there is an assembly present, you can click and you can see values. We will use this later to get an idea. What is extremely important, and I really hope that you will make use of it, is that if you don't know what something is and you want some more information about it, there's a very nice help button here. So it's an invoke context sensitive help. So if you click here and you go somewhere, anywhere on this screen, and you click on that one, it's going to connect you to the help page of the ABAQUS documentation. And if you we clicked somewhere on the model tree, you will see it'll take you to the model tree, and you can see all kinds of options here as to what you wanted help with. And this is possible on this main window of ABAQUS anywhere. So let's explore all the other options as well during every tutorial that we follow in the classroom and online. Please make sure you complete all the tutorials also on your own. So don't just watch it being done here, but also do it yourself and try to click on all different kinds of buttons. Don't be afraid to make mistakes. Of course, make sure that you save your models at different versions if you are afraid that you are going to lose your data, but we are going to work with very simple models. So recreating them from scratch won't be a very big effort. However, just to save time and to save panic situations, keep saving your model. Thank you for watching, and we will pick up the first example problem in the next following video.